Hi, my name is Feng Luo. Today's topic is about the simulation on airport check-in and through security. So the first question is about identify the sequence of events for this example. So you can see from the graph, I create the one sequence graph for this, the passenger, the check-in, and the security screening. So the passenger arrive, they'll ask the check-in agents to check the ticket and select seats and also load the luggage. And once they finish this process, they will be issued a boarding pass. And after this, the passengers can go to the security gate to check their boarding pass and their identity and do the carry-on luggage security screening. And they'll be past the gate and entering the airport. So this graph is a talk about the basic UIs like passengers and they go into the queue area and they wait for queue and they'll be called out to the different counters. So that's about it. And second question about what kind of expenses are associated with the sequence of events in the airport. So from the left side, I gave those expenses. The right side, according to the right side event. So when passenger arrive to the check-in point, those check-in will be have a agents like employee in the airport that you need to pay for them, right? And also we have the counter area and also the waiting zone. You also need to have the square face to take to for those things. And also we may have the self service machine, a kiosk normally you will see on the airport. And also the lights and powers. And for security gate, also we'll talk about the agents, the employee, and also the security booth, and all the other equipment we need to pay. That's the money, that's the cost. And the third question is about what do you think is the reason for building such simulation in this example? So according to the simulation, we are thinking is proper or is we should create a simulation is like the lower cost, the efficiency, and also the random data inputs and existing popular model we can use, or is this simulation we have already have some feasible algorithm or data structure to support the implementation. So the simulation can answer the question like those without the expense associated with changing the actual system. So for actual experiment, if you want to change the any aspects of the system, you need to pay for the money, right? But in the simulation, you can easily increase the number of the agents, a number of the self-service machine or the gates or other properties without any cost. And also ticketing, like I said, right? The ticketing agent, security booth, those those are the cost. So and also it's pretty time saving. Imagine in real case if you arranging those resources, which is pretty time consuming. But in the simulation, you can easily change those properties and random data inputs. So you can change any aspects of the system to to see how you affect, like I mentioned before. Those property you can change anytime. And according to this scenario, we are be considering the multiple server queue system. These are well known. A lot solution implementation we can get from the community. The next question is about is building a simulation appropriate for this example? I mean, you will see this question is not about the results will be reliable. It's more about whether it's cost effective. considering small business, the owner may not able to afford the simulation cost, but considering for the big airport, right? They can afford compared to they doing the real experiment. I think the simulation cost will be huge saves for them because you just need to using the computer write the programs with all the aspects, and later on you can use over again. Those are just pretty efficient and also with low cost. So the next question about what are the main questions to be answered by this simulation. So I list out those bullets. First one is like a given. We know how many people will be traveling through the airport at a given day, and we can figure out how many staff we need to make sure that a profit is made without making customer missing their flights or get too hungry. That's one. Another one is we can get an idea about the average service time when checking and also the average time through the security, and also giving the condition. The condition you can give based on your design, and you can see the best space allocation plan. Say how many space you want to give the waiting zone, or how many space for the security gate. That's kind of the result we can get. And also given that we know how many people, given that those conditions, we know how many people will be traveling, and we can see the best resource management plan. Those are means resource means the equipment, the people, agents, all the cost. Those are resource. We can come up with a good plan. So next question about how we what is the data structure we can use to implement the queue. Normally we'll be considering using the stack to implement the queue, the first in first out. Since we have the specific scenario like someone can get into the queue anytime and in any place. So for this case, I think the linked list will be the good fit for this, because linked list you can easily insert one entry, one node in between. Just change the pointer. I think that's pretty easy for a linked list. And the last question about the list of any the other variable data that needs to be captured in this simulation, and explain the role and also explain why they are necessary in order to be able to implement the simulation. So I list all of those. Maybe they are not enough, but that's my understanding. So arrival time, because for queue system we are all worry about the arrival time and departure time, both for the checking and the security gate. That we can get because you can using the departure time to manage arrival time. You can get the entire process time, and also the checking zone area. That this is referred to the space allocation, and we can change the area, and also we can change the number of passengers and number of the staff counters or self-service kiosk. Those are the self-service machine, and number of the security gates or number of the agents, and the wait time before you enter the line, when you will be get call out for next service, and also the service time. The last one is about the total number of equivalent check-in positions. This is referred to how many lines you can wait. You know, right? In the airport check-in will be you can enter in different lines, and you don't need to just have a single huge line. Those are the properties in this simulation you can change based on your design, or what's the questions you want to answer. If you say like you want to come up with a good space allocation plan, so you can change the area, the scroll phase for different area like the security gate or checking area, and also you want to design the cost you made to change those number of the accounts or those machines or equipment to come up to see how the cost will be. And also you can control the passengers number, and you can you can also change the service time and to see how it can affect in the final output. Basically, those are the properties you can manage and manipulate in the entire simulation process, which will give you the different output, give you the knowledge and insights about the original system, and you may get an idea to how to enhance the entire flow or enhance the service quality, something like that. So yeah, I think that's it. Thank you.